Okay, so let me share my screen. And just let me know if you can see it.
Yes.
Okay, so today we will be talking about migrating project from SkiaSharp to Microsoft Maui graphics. So a few words about me. So as Bogusław mentioned, we are Xamarin developers. I'm Xamarin developer at PGS Software. I work at the moment with the Xamarin native stack. I'm also creator of Magic Gradients, and also I'm co-organizer of this meetup group that we are currently on. And you can contact me on GitHub or on Twitter. Okay, so for people who don't know what the Magic Gradients is, so basically it's a Xamarin.Forms library for drawing gradients, and it's done using SkiaSharp for the cross-platform drawing API, and it's supporting, of course, Android, iOS, UWP, and all of the platforms that are supported by Xamarin.Forms and SkiaSharp. And now you may ask question, why? Why do we need another library for drawing gradients when we already had PancakeView as a third-party library, and now we have also a built-in solution, which is brushes, that can also be used to draw gradients inside forms and also in the Maui. Yeah, so to answer this question, we can ask another question: what really the gradient is? Because when we say gradients, most of us see something that we see here on the left. So simple linear gradients with some colors going from one to another. But also gradient can do something more. We can use gradients to draw them in layers, and we can mix linear gradients, radial gradients, use some transparency effects to achieve effects that we see on the other pictures. So we can have more like abstract backgrounds, more like textures than typical gradients. And that was the idea. So create control that will be able to draw those complex gradients, to draw a backgrounds that we can use as a page backgrounds, background in some headers, in profile pages, without using any graphics at all, only using platform drawing. And having said that, we designed some core concept of the library that we are following since today, at least for the version that we have now on released as a nugget. So the first thing is that, as I mentioned, Magic Gradients were designed purely to work with Xamarin.Forms. So we have there a lot of dependencies on the forms types. Gradients itself that we define in XAML are bindable objects. There are a lot of bindable properties. We have also some markup extensions. So all the goodies that we have from Xamarin.Forms. We also, since the beginning, wanted to have cross-platform drawing API. So yeah, we are using cross-platform technology, so we don't want to care about how do we draw gradient on iOS, on Android. Just give us an API that we can work with and do it once, and focus on our stuff for the complex gradients. So obviously, at the time when we were creating this library, SkiaSharp was the natural pick for this purpose. And the second thing, which is also very important, we have high support for CSS gradients, because CSS itself provides great and flexible API for drawing complex gradients. And what we want to achieve is to be able to take those CSS gradients and just use them in Xamarin.Forms apps. So we have a parser that is taking the code directly, code of the CSS gradients, and then it's drawing them exactly like the browsers do with the CSS. Okay, and then we introduce also some extra features later, like built-in exam animations. So they are built around animation class for the Xamarin.Forms. So we have here animations, standard animations like property animations, where we can take start value, end value, and animate this with some easing. But we also have storyboards and keyframe animations. So we can take value of a property and change it over a time in different time frames. And those animations can be used to any part of the gradients. So we can animate gradient itself, you can animate any stop of the gradients, because they are designed to work at the bindable object level. So we don't have to provide the visual element as the target, but the bindable object is fine for them. We also have a feature that we called clipping mask. So it was born from the idea that it would be nice to have a text painted with gradient. But in SkiaSharp, it's easy to turn text into to a path. So when we have the ability, so if we want to have ability to use clipping of a path, let's extend this functionality. It was what we thought. And we added possibility to use the data from SVG images, and we also added rectangles and ellipses to that system. And this is how the overall clipping mask feature was born. And also we provide CPU and GPU rendering for the gradients, which is quite easy in SkiaSharp. We are just extending different control, and we have OpenGL or DirectX on the UWP acceleration, which makes the performance better, especially when we are drawing radial gradients on UWP. So the performance boost is very noticeable. Okay, so we developed the library. We ship it as a nugget, and in general, people like it. We have some users who like how it works, but there are two main complaints about the library. So one of them is that it was designed for Xamarin.Forms, so it can be used in different platforms. So now we can't use it in Xamarin Native, we can use it in UWP or in other flavors of XAMPP-based languages. So for some people, that was an issue. And also we have a dependency on SkiaSharp, which, because we have to embed the Skia itself to the APK, it makes whole app a little bigger than if we used native drawings. But because those are core concepts from the beginning, we always were saying that, sorry, but we can't change it. This is what you get for the moment. But then when Maui was introduced, there was new drawing API in town, which is called Microsoft Maui Graphics. So what is that library? So basically, it's a cross-platform drawing API that gives us two basic things: iCanvas, which is abstraction of some kind of canvas, and draw method. And with those things, we just do the drawings, and basically it's just the abstraction over different implementations. So as a base implementation, there is Android graphics and core graphics. And for that, we don't need additional external libraries for drawing. We can also use SkiaSharp as drawing backend and also SharpDX. Also, Microsoft Maui Graphics provides some basic types that are often used for drawing, as Javier mentioned. So we have here some rectangles, colors, points. So everything that some drawing library needs to make a calculations, to define colors. And also what is interesting is that those types are also shipped with converters. So we can use Microsoft Maui in any XAML-based library. And those converters, which is important, are from system component model namespace, not the Xamarin.Forms namespace. So this is something that is part of core.NET. So again, no other dependencies here. And the name of the library may be confusing for some people, because it may suggest that this is something that has dependency on Maui, but it's not. It's quite opposite. As Javier mentioned, Maui has dependency on the Microsoft Maui graphics, and it's using those types and those drawing methods on canvas to do the low-level drawing. But we can also use Microsoft Maui graphics now with the Xamarin.Forms as well. And this is what we are doing now for Migrating gradients. So we didn't port it, the drawing to the, maybe not the drawing, but the XAML bindable object part to Maui. We are still using Xamarin.Forms namespaces, but we can use now Microsoft Maui for drawing. Okay, so before we go to the issues that I had during the porting, so I just want to say that most of the functionality that we do in Magic Gradients went well. So Microsoft Maui provides now methods for drawing linear and radial gradients, which is the thing that we are most interested in. So that went well. Of course, when I start looking at this library, there was actually no documentation, so I had to spend time on learning basically how it works, how it differs from SkiaSharp, what is possible there, what are the limitations, is it worth to move the functionality that we have, because we have some advanced drawing gradients. But the result of this research was a green light that yes, we can use it. So I started porting this, and yeah, most of the functionality went well, but there were some issues that I faced during that process. Okay, so the first thing that I think was the most strange to me is how the scaling works in the Microsoft Maui graphics. So I call it scaling does not scale. So what I meant by this is a kind of different than the scaling is done, for example, in SkiaSharp. I will be referring to SkiaSharp because this is the API that I know the best. So when we do scale on canvas in SkiaSharp, there is made a internal transformation for the canvas, and we don't have to care about any special calculations that will take this scale for the calculations. Yes, because it's done automatically. We are working exactly the same as the scale would be the base one, so 1. In the Microsoft Maui graphics, scale is just a value that is saved in the canvas state. So those four images four snippets that we see that are examples of how scale is used in the shared abstraction and also in the Android implementation of the canvas. So from the left to right, from top to bottom, there is the direction how the methods are called. So first one scale is from the scaling canvas, which I will talk about for a moment more. So it's storing its internal scale. And also it's calling canvas scale, but this canvas scale, it's not the canvas implementation, but it's the abstract canvas, which is also storing the scale in the state. Then it's calling the native scale, and the native scale here is the from the Android implementation. In the native scale, we are setting scale for the current state. And in current state, the setScale method, again, it's storing its private field scale. But as you can see, there is no direct call to the native canvas that just invoke the scaling. And I think for the libraries, okay, and there's also a helper library called scaling canvas, which is basically wrapper over the abstract canvas. So over the, or not the abstract canvas, but over the native implementation of the canvas. And it's dealing most of the calculations itself. So all the translations, drawing, clipping, internally, it's using those scales from the state. And everything is usually working fine, but things start to be complicated when we start doing not the simple translation from the canvas method, but we start to using matrix concatenation. So a bit more advanced way of changing the transforms. And the way how the scale is complicated here, we may end up that our calculation code that we are porting from SkiaSharp to Microsoft Maui graphics may not work, and must be adjusted. And we probably don't want to change that. We want to have the drawing code almost exactly the same, of course, with some API changes, but with no calculation changes. And we faced such issue in the Magic Gradients as well, but I will explain it later when I show you the code.
Are you going to share later? Maybe I will be interested in see the current SkiaSharp code related with scaling, and if you can share a little bit what are the operations that you need to do with some matrix or something like that to know exactly what are the kind of operations that you are doing and how we can change this part.
Yeah, I will show you later in the code.
Okay.
Okay, so let's move on. So next thing is transfer property. It's something that we have available in the canvas of the SkiaSharp. So basically, we have here this piece of code. We are doing something like that we want to store the current transformation in Magic Gradients. Then we are doing some transformations that we need for clipping. Then we do the clipping, and then we restore the previous transformation, because we don't want to have this transformation in the drawing code only for the clipping, but we can't just restore the state, because by restoring state, we would lose the clipping, because at least in SkiaSharp, clipping is part of the state. So if we restore the state, we lose the clipping. So basically, just what we wanted to do was to get the current state, do some transformations, and then restored only the not the whole state, but the transformations that we did. Yeah, so this property is missing from in the iCanvas, so we had to make a workaround for this. And
yeah, it is missing. There are some transform methods that expect some matrix parameter in, for example, the path that is mostly used to define any shape and other case. But I get when you want to try to use that with the Skia, that probably is to apply some gradients to, well, get some path from text, right, and apply then the transformation and the gradient to this text.
yeah, because we have something like a basic layout for those shapes, which are basically some similar to layouts that we have in images. So we can do the fill, aspect fit, and it's doing some translation, scale, and then again translation. We do the clipping, and then we want to revert those transformations only, but not the clipping. So what we do now, we are just recording all those steps that we do. So translations, matrix, translation, scale, translation. We are doing clipping, and then we are just applying them with reversed order and with different directions. So instead of applying fully the transformation metrics, we are just taking all the steps and using them in different order and the reversed values. So this is how we do workaround for this. Because in iCanvas, we have only concatenate transform, which is something that take whenever transform you have and do some transformations, but we can't tell what the transformation is now, because in the shared code, there is no such property. I know that there is in Canvas state the transform, I think, property, which is called like that, but it's not accessible from this iCanvas abstraction. Okay, and the next things that I show you here are just strongly related to the gradients, and yeah, they just basically don't implement it yet, or in a more basic kind in the Microsoft Maui graphics. So at the moment, to draw radial gradient, we can only specify the single radius, which allow us basically to draw a circle. And with Magic Gradients, we are also allowing for drawing ellipses, which is needed for some CSS code that we can use. And because of this limitation, this is again some sample code from the Microsoft Maui graphics, so we can use single radius value. And in SkiaSharp, there was also single radius that we could use, but when we were drawing gradient, we were basically just creating shader, and for the shader, we could specify the internal matrix. So by using this matrix, we could simulate those two values, and basically we were having the effect of circle instead of effect of ellipse instead of circle. I will also show you that later in the code. How did we work around this?
Cool.
Okay, and the next thing is the lack of tile mode repeat, because Magic Gradients also can draw repeating gradients, which is also quite common in CSS world. And as you can see in the implementation, there is tile mode hard-coded to be clamp. So this is why some gradients can be exact moved from the old implementation. And the last thing is no support for clipping modes. Maybe I didn't found it but what we allow in Magic Gradients is to have how we call it include or exclude. So if we have some shape here, like there is Zamagon on the left, so we can take the whole space and just paint the shape that we specify. So the region that we have as a path data, we are painting it. And in the second mode, which we called exclude, we are drawing the gradients the whole surface, and the shape we are just cutting out, and it's transparent, so we can show something behind this.
So there is not available what exactly you need. Yeah, there are options to use clip to cut some part of the canvas using some specific shapes or some specific stuff, but it's not exactly what you are using in Skia. So yeah, we can say that this part is missing. Probably we can apply some workaround for now, but definitely it's not exactly the same.
Yeah, so the left image, we have it already working in the Microsoft Maui graphics, so that is fine. We can take the data from any SVG image. There are methods in the Microsoft Maui graphics that can turn this data into the path object, and we can do it for clip path method. So yeah, that is already there, but the second one is. Okay, so those were all the issues that we encountered. So not many of them. So you can find source code of Magic Gradients on the GitHub. You can also scan the QR code here to go to that page. We have quite complex documentation with some pictures and samples how to use Magic Gradient in XAML, how to use CSS, which in CSS is which parts of CSS are supported. You can also find some examples, some animation stuff, and such. Okay, so that's all for the slides. I may now switch to the Visual Studio and show you how the project looks. So this is what we have now on the master branch, main branch for the project structure. So Magic Gradients Core is the main project. It has only dependency. It has only dependency on the Microsoft Maui graphics, so no Xamarin.Forms here. So we can easily use it in the native. This is the plan, to be able to use Magic Gradients also in native projects. So here there is a standard basic calculation stuff, drawing stuff, some parsing, and base code for masks. And we also have some converters as well, which are converting our own types, and the converter, the same as Microsoft Maui graphics, are from system component model. So it's something that is built into the .NET.
Just a quick question related with converters. So the converters API, well, so far this is a Xamarin.Forms project, but in .NET Maui, the converters API will be exactly the same. I mean, will be exactly the same interface and the same methods to implement. But my question is related with the basic types. So probably before in Magic Gradient, you was using the Xamarin.Forms basic types.
Yes.
I'm talking about types like the point, like color, like maybe vector and all this stuff. And probably you have changed that to use Microsoft Maui graphics types.
Yes.
There are some basic changes that we have done, and we had some discussions. Some ones are really interesting based on the default types and based on the extension methods that we include with every type. So for example, in Xamarin.Forms, there was an enumeration with color.default option. And well, this is probably use a basic example, but now, for example, the default value for a color in .NET Maui is a null directly. So my question is, did you find many issues or many problems just converting the types?
From Xamarin.Forms to the Maui graphics, yeah?
Exactly, yeah.
Only for color, because to have that was just naming issues. So because I think there is a colors with S at the end static class, the colors names,
yeah.
and it was, I think, only difference that I encountered.
Okay,
So
that's good.
That was let me.
The other big change maybe in color is if you are converting between different, between, for example, RGB to hexadecimal colors, etc. The methods to use that have changed a little bit. The good news is like now it's more powerful because you can do conversions between more different types. But definitely there is a small breaking chain there. It's just replace a name, but from the method. But I was curious if you find many issues with this.
Yeah, so this is the place where I had compilation issue, as I mentioned. So now there is colors dot, yeah, and before there was color dot and named color, and also we have some in the parsing. We have some color parsing as well, and we just here color parse, and we are basically trying to parse hex colors, named colors, and RGBA colors that we could have, for example, in CSS, and no issues here. So parsing works is working as before. So
okay.
Okay, and so maybe I can show you the main purpose of this project, so the Magic Gradients core, so the drawing itself. So I try to follow the approach that you already have in the Maui graphics and also Maui graphics controls that you mentioned. I didn't want to reinvent the wheel here. So I have just the gradient drawable class, which is implementing iDrawable, and it's just calling the draw, so something that is familiar for everyone who work with this Microsoft Maui graphics. And here, besides of some calculations, we are just getting the gradients. Here we are getting paint. And also, as you can see, in this project, we are using interfaces rather than actual implementations, because there will be different implementation on the linear gradient for forms, which is using every binding stuff for forms, and different for Maui. So here only interfaces. We set this fill paint, and then we just draw the gradient, which is quite typical drawing stuff. There is also some calculations involved here, because we can also draw tiled gradients, because we support CSS property, which is called background size. So you don't paint the whole surface, but the size that you specify. So we can tile the whole gradients. So we have those loops here. But here we just saving state, doing some translations. We are doing clipping, drawing, and restoring state for this draw operation. So this is for the core project. In the forms, so here we have all the forms stuff, so all the XAML types, all the bindable objects, or the bindable properties, and also we have again something similar that you have in the Microsoft Maui graphics control, which is graphics view. which is basically a simple view for holding the eye drawable, and we have here now basic
It's funny
renderers.
because I just updated the Maui implementation of graphics view, having an invalidate method and some events like invalidated and other stuff. But yeah, it's mostly use a view with a drawable bindable property.
Yeah, and we have some here simple renderers just basically are creating native implementations for the canvas.
Cool.
Yeah, and as I mentioned here, we have all the gradients that are bindable things. So we have bindable properties, so something that couldn't be before this whole refactoring to the Microsoft Maui graphics. It was very hard coded. It was part of the, as I mentioned, core concepts. So it was really hard to take it away from the base part of the library. But now we have interfaces for everything. So as a base type, we have gradient element, which is bindable object, and it's dealing some refreshing of the images of the canvas, invalidate canvas. Yeah.
Yeah, that's a good idea. Mostly if you want to have the same, share as much as possible, reaching also as much frameworks as possible. That's definitely a good idea that will help to move quickly in that direction.
Yes. I was also looking at the code generators in C# 9 as they are used in the Comet, so I could use those interfaces and generate some bindable stuff for forms and for Maui, because this is a lot of boilerplate code, which basically will be the same for the forms and for the Maui, but with different namespaces. So maybe I will try to make
that's a good idea. I have done some tests with in that direction. For example, with the Microsoft Maui graphics control library, that is just the library creating the drone controls using Maui graphics. One of the ideas that I think that would be really interesting, mostly for developers and for the community, is, for example, today we have, and we are working in a .NET Maui toolkit, but of course also sees a Windows community toolkit. And one of the main questions that many developers have many times is, do we share controls? Could someone create, for example, a data grid control in the Windows community toolkit and use it directly in Maui? Of course, the short answer directly is no. It's not possible by many reasons. But what if we could have used a graphics view working in both frameworks, and the code of the control is a drone control, so the code will be exactly the same, or this shared code that probably you can show in this case. I mean, the canvas, the draw method, and draw everything. And then the only different thing between, in this case, WinUI and Maui will be the properties, dependency property and bindable property. And in that case, it's something that we could generate. So I have played with that in that direction. I could do some commits and share with you the code in case you are interested in explore this way. But definitely it's an option, and it's something really interesting that could cover this case.
Yeah, that would be great. Okay, so and the last project that is important here is the Forms Skia, which is basically extending the Forms functionality with SkiaSharp Nugget. So everything that is not possible in the current Microsoft Maui abstraction, here we can directly reference canvas as Skia canvas, and we can fill all the gaps that are not possible now in the abstraction. So we have here Skia Canvas X, which is extended Skia Canvas, and Skia Canvas is a class that is part of Microsoft Maui Graphics Skia. And here we are. Let me show you the references here. So we are referencing SkiaSharp views forms and Microsoft Maui graphics Skia. So having this here, we can do the remaining stuff that is not possible in the forms-based implementation.
I see.
Okay, so maybe now I will show you the problems that I had that I was mentioning about in the code and how we solve it. So let's start maybe with these transformations and masks. And yeah, so as I said, for mask we have a class called mask layout, which has one single method, which is basically trying to position the shape that is clipping, and there is some first translation, then there is some scaling based on the stretching settings, and then we have the end layout. Yeah, so basically what those methods are doing, they are overridden in some cases, but basically they are going to the center of the canvas. Then we do the scaling, and then we go to the place where we should start applying the clipping itself, and that's it. And of course, as I said, and after applying this layout, I wanted to revert those transformations. And the problem I had was that initial idea was to create one offline transform. I think now it's called different, but the version that I'm using is still offline transform. I think now it's been renamed to the matrix something.
Yeah. We are renaming some basic types. In some cases, are used to align the naming with other Microsoft frameworks, like for example, what you can find, for example, in WPF, etc. And people that comes from that frameworks find this more easy to follow, understand, etc. And then we have used one case that we are still debating, and is about, for example, the rectangle. It's a good name, but also in other frameworks we use directory rec of naming. And also we have one small issue that is like we have a rectangle reserve name to define the shape, to represent the rectangle shape, for example, in XAML or in C#. And we also have rectangle struct to define, the positioning and the size. And in that case, we could fix that just maintaining the rectangle name and using different alias in XAML, different namespaces, etc. That's one option. And other option that we are talking about is maybe rename to rect. So will not be huge change, but yeah, a couple of types could change their name from now until maybe end of the year. Yeah.
Yeah, okay. So, but there won't be conflicts in the naming if you change it. Okay, and so the idea was to have one single transform, and when I was doing all the translation and scaling, I wasn't doing it directly on the canvas, but I have small method here when I'm doing actual translation. And I was building the matrix because I couldn't get the current matrix. The idea was to build the matrix that holds all the transformation I have, then reverse the values and apply this matrix on the canvas. And this is what I was doing here. So I just was calling those translate and scale on the matrix. And at the end of the transformations, I wanted to restore the transformation state with this matrix. But those calculations were basically wrong. So in SkiaSharp, they were working fine because after we applied scale, let's say 2, the next translation was still not multiplied by scale. And when we reverted this, it was fine because when we say move translate for 100 pixels, SkiaSharp internally was changing those based on the scale, and we didn't have to put the multiplication inside the code. But when we are doing that with Microsoft Maui graphics, and we are telling mega translations, and we have scale too, under the hood, it's getting those values and multiplying it by 2. So when we try to revert it, we have to know that the real translation was not the 100 pixels, but it was multiplied by the scale. And we have to do those additional calculations when we are reverting this process. So because of that, because I didn't want to complicate and add additional multiplies and add here confusion about the scaling, what I did instead, I created stack of transforms, and I'm just putting to the stack every transformations that I'm doing here. And then I'm just going in the reverse order, and I'm reversing the values, and I'm basically here, I'm relying fully on the scaling canvas, so I don't have to care about those calculations with the scaling canvas is doing this for me. But I'm not applying the matrix itself. I'm just using matrix to get the transformation data, but I'm not concatenating the matrices. So I found this solution to be working fine in Skia implementation and also in the native implementations as well. Yeah, so this is first issue. Second one was about those missing drawing properties like tile mode repeat or radius for radial gradient. So what I created here is just the classes that are extending the base linear gradient paint and radial gradient paint, which are part of the Microsoft Maui graphics. And I'm just adding the properties that are missing there. And those objects, when they are used in the native implementation, Microsoft Maui graphics, they just don't care about these properties, because this paint is still linear gradient. So when Maui graphics is reading the gradient data, it's just ignoring this property, is repeating, or for the radial gradient, I have size, which can have width and height, and also again the repeating. And for the Skia implementation, I have something like here. So I'm overriding the set fill paint for the Skia canvas, and I'm looking if this is the extended paint, not the basic one. If yes, I'm taking advantage of those additional properties for drawing, and then I'm doing basically exactly that we do in the pure Skia implementation. So I'm just basically creating a shader. Here I can make use of this is repeating and use the repeat or clamp. So this is the part that I showed that was hard-coded in the Microsoft Maui graphics. And I'm setting here fill paint shader. This is for the linear gradient, and for radial gradient, I have those two values for radius, x and y, x and y, and I'm here when creating shader, I can specify the matrix. So I'm taking those two values, and basically I'm calculating proper matrix that will make ellipse from the circle. So this is internal transformation just for this shader for radial gradients. So this is how I'm solving that part.
I see. Well, the interesting part from all this is like currently in Microsoft Maui graphics there is like 6 different kinds of paints objects. For example, the radial gradient and linear gradient paints are types of these objects, but also there is an image paint to just render image, and there is a pattern paint that also have some parameters to define what will be the pattern and how you will repeat the pattern. So internally, in every implementation, we have mostly the logic to do the repeat logic. So the should not be something complex to include. Probably the best solution in this case is extend the current linear gradient and radial gradient paint implementations, including more parameters, and
Yeah.
take a look to the current code from the pattern paint implementation, and also apply how to repeat, in this case, the gradient. But yeah, for now it's a nice workaround, but definitely this is easy to fix at Maui graphics level.
Yeah, as I was looking at the code, it would be pretty easy to do the implementation on the Android, but I don't know well other implementations for the drawing, so I'm not sure about the iOS and other platforms.
Well, I think that in the case of Android, iOS, I don't worry too much, but also there is some implementations, and of course Skia and others, but there are really other implementations where I really need to take a look. For example, in Windows, there are like 3-4 implementations, one of them using just directly the Windows Drawing API, using Win2D, using I don't know, SharpDX. There are different implementations. I'm not sure about SharpDX. Need to take a look, but for sure it's possible. And also there are some implementation, for example, with WebGL. And I guess that is possible, but in that case, I'm not totally sure about this. So yeah, one of the first things that we need to do is review how to do in every platform, and what can we achieve in all the platforms, because at the end
Yes,
we need to render exactly the same everywhere.
yeah.
And that's
It may look easy on the Android, but it may happen that on some implementations that is basically just not possible. So, so yeah, there is a question: so is it feature so needed that we want to put a lot of work to making it work on platforms where it's not as easy as on the Android, or maybe do we need it at all? Yeah.
yeah. Need to
Okay.
review that. Need to review that and check some of the case, some of the platforms. Yeah, definitely the change at the abstraction at the API level, it's easy, and some of the platforms I think that are really easy too, but need to check all the case and all the platforms. Yeah.
Yeah, and the last thing about the clipping operations, so it's implemented only in the Skia extension, and here we are just taking get native canvas. We are using such method, but basically it's just casting the native canvas, because we know that we are here in the Skia world, so we can safely use the Skia canvas, and we are just using clip path, and there is an extension method, which is basically taking this clipping mode and converting to the SK clip operation intersect and difference. That's how it's done in the Skia. Okay, so this is all that I wanted to show from the code. Maybe I will run this example, because we have also here the test project, which is called Playground Maui. I think Playground is the best name for every test project. So everything that we have in Magic Gradient is Playground something.
It's always a good name.
Yeah, too much time spent in MVM Cross, where also there is a Playground app. Okay, so this application I'm using to compare the current drawing that we have in pure Skia project and to the Skia with Microsoft Maui graphics, and to the Microsoft Maui graphics without Skia. So these are some basic linear gradients. So here you can see that this is basically repeating gradient, and for the Skia and graphics Skia, it's fine, and we are missing this property in the native, so it's drawing like a clump. Yeah, so those are just basic drawings. So we have three ways how the drawing is implemented. So it's easy to compare it, because debugging drawing from the code may be hard. So it's always easy to look and compare if it's rendered correctly. And again, we have Radial Gradient, which is supposed to be drawn as ellipse, but in the native implementation, it's just a circle. Here there are some tests with masks. So this is pure Skia implementation. This is Skia with Maui graphics, and this is Maui graphics without Skia. So path is working also fine. And for text, text is only implemented on the Skia extension, because I didn't find an easy way to convert text to the path in the Microsoft Maui graphics. So this one is only in the Skia. Yeah, and I think most interesting part is here is the gallery. So we took some gradients from the web, and we have keep them in the library, in the database, sorry, and they are grouped in some categories. So for example, we can go for the standard circles, and here we can see how they are rendered for each backend. And especially for native Maui graphics, there are some differences. So we can compare them all together, but you can also see here Skia graphics, Skia and graphics native. So we can easily compare that there are some differences in drawing. And again, with linear gradients, it's pretty much working the same as, sorry, these are pretty much the same everywhere, but the difference starting to appear when we start doing something with circles. So this is because a lot of those circles need to be ellipses, so it will look like this. That's why we have those differences. Okay, so this is the test app that we use for the drawing. And maybe at the end, I will also, maybe you have a questions to this part of the code.
Well, for my part, first of all, congrats for reach this level and in this timing, because we still don't have samples or even too much or documentation or solid documentation about this. So thanks for take your time and explore the library and play with it, etc. And for the rest, for me, it's as being a super useful conversation, because there are some things like, for example, the ellipse with circular stuff, or the option about repeat the gradients that probably we could cover and could improve without, I think, big effort. There are other parts where I think that we really need to review it with more details, like, for example, all the part related with masking is a little bit more complex based on some platforms. But yeah, I think that we need to review this part, and hopefully will be possible. But definitely really helpful and useful for us to continue improving the library. We talked a little bit about that at the beginning. There are still not documentation. This is something that will arrive, and we are still in some conversations about change and naming and some methods parameters and some stuff to align this a little bit more with SkiaSharp and allow a smooth transition from Skia without big refactoring or big change. So this kind of projects help us a lot to know what are the areas where we need to put more effort and more focus. So I take a lot of notes during the session, and hopefully we'll be able to create some specs, and we will continue improving the library. And in upcoming Magic Gradient versions, probably you will need less change or less workarounds, etc. But not big questions. Thanks so much to share very clearly what are the issues that you find, the workarounds that you did, and yeah, that's really helpful for us. So thanks so much.
Thank you. And maybe as a bonus, I can show you the current big testing app that now it's running the Magic Gradients, which is still pure in SkiaSharp. This is the UVP project. So initially, it was only the testing app that similar to what I show you before, but while we were playing with that, we created more or less editor for the gradients. So yeah, where we can browse some properties of the gradients that we support. And the gradients are generated randomly, so we can here test easily what is possible with gradients. There is option for a single or repeating. We have simple editor for colors. So if we start playing around with the gradient stops, we can see that where it starts to repeat itself. So the green, the place where the repeating ends.
That color picker looks really nice. If you have something implemented in the different platforms, remember that yeah, the toolkit is always an option. I mean, if you don't want to create a specific library with the picker, etc., the community toolkit is always a nice place to put this kind of controls, just as a note in case you want it.
Yeah. Okay. Yeah, so we can specify in hex or RGBA. There is also part of testing sizes. So we can change the size, and now we are drawing a styling. So I was showing that in the code. And also we can test masks here as well. So we can show how rectangle mask works. So each corner can be changed individually by 2 dimensions. So see how it changes. Yeah, there is include, exclude for this one. For ellipse, yeah, so nothing very special for ellipse. We can just change the size, show the clipping modes, test if it's drawn correctly. More interesting is probably the text itself, so we can change the font size. We can change positioning here, vertical, horizontal text alignment, so the same as we have in the every text control in Xamarin.Forms right now. We have some simple ways of alignment of the text. And also we have a path mask that we can test here. We can include this, exclude, test. So those basically are those layouts that I was showing in the code. So different ways of aligning path. We can also pick something different here from this simple picker. Yeah, so this is about the gradient editor. So Radial is basically almost the same, but we can specify the positions here. We can also use dragging to change the position of the gradient, and other tabs are basically the same. We can also preview here how the CSS functions are being parsed and drawn. So we can, for example, type here linear so it's being parsed while we type. So it can be used to track the CSS gradients that we find on the web. There is also gallery, which is using the same database as I showed for the second test app. So we can see here many different types of gradients. They are exported from the, they are just basically CSS codes. Sources, we can also pick theme to see, for example, only gradients that has shades of red. And this radial picker is drawn in SkiaSharp, so it's not any external.
Was just unmuting me to asking that if was a Skia of was. Yeah. Okay.
Yeah. This is just the Skia drawing with some small animations. Yeah, and here we can see how the animations. I also was mentioning the animations for radial gradients for the magic gradient. So here is a simple animation of the angle property. Here is animation of color property. Here we are animating the center property of a gradient. Here we can animate the dimensions, so how the tiling changes when the size is being changed. Here is the storyboard, so we have couple animations running all together. So we are animating two gradients. Here is point keyframe animations. So we have a point property with changes during the time. So we have 4 keyframes for every corner. And here are just other examples how we can use gradient animation to achieve some effects. And of course, masks that I was also mentioning. So by using some different shapes, we can achieve such effects with those gradients. We can do something like this. So it was trying to mimic the loading screen on an Xbox. So with a bit of creativity, we can create such effects. So this is just a circle with radial gradient a bit adjusted, shifted, and just the path mask, which is doing the Xbox logo. And here as well, one gradient, second radial gradient, and
yeah,
also some effect here, and the shadow effect from the. This is made by doing the transformation on the y-axis. Okay, so that's it for this app, and this is all that I prepared for today. So I don't know if.
Okay, so I will stop recording. Once again, say thank you to Martin as well as Bogdan, our also Bogdan who is MVP also, and me who is still leader here. So okay, so I'm stopping recording. Bogdan, okay, you have your time.
You forgot to say thanks for our special guest, or maybe I missed that. Just a moment, need to open the door. Sorry, I'll start speaking more.
Don't worry.
Okay, I'm stopping recording. Where's the button? Stop recording. Okay.